Today going to the PAT paper in 2009, looking at question 10. So question 10 gives us this figure here of 3 circles inside an equilateral triangle and asks us to find an expression for the ratio of the area of the circles to the triangle. Now, there isn't actually any information given to us about the lengths of the sides or the radius of the circle or anything like that, so we're going to define everything ourselves. So let's start by defining the radius of a circle to be r. Okay, and well, let's draw that on here as well and think about how we can go about solving this. Well, clearly we need to find the length of one of these sides. So we have an angle, if we have one side length, we have this side length, then we can find the area of the circle, of the triangle, and then we can find the area of the circle in terms of r. And hopefully if we can find the area of this triangle in terms of r, it'll all cancel off and we'll just have numerical values, because we can't have r in the expression because we've defined that ourselves. So what do we need? Well, we need to find the length of this side. So let's split it up. What is the length of this section here? Well, we don't know. What this section here? Well, we see that, in fact, this is 1 radius plus 1 radius. So that's of length 2r. And clearly we have 90 degrees here and here. So this is of length 2r. And by symmetry, this side is the same length as this side. So let's label them x. And we're trying to find x now. How can we go about doing that? Well, let's try and make a triangle here and here. And the reason we would do that is because we know the size of this angle is 60, and this will bisect it to give us an angle of 30 degrees. We have one side, and then we want to find this side. So we can use trigonometry to find x. So let's label on 30 degrees to our diagrams. And we can read off that, in fact, tan of 30 degrees is opposite over adjacent, r over x. And tan of 30 degrees is root 3. Sorry, 1 over root 3. Which tells us that, in fact, x is equal to root 3r. Well, now we have the length of our side. So side of triangle is now equal to, well, clearly 2r plus 2x. So that's 2r plus 2 root 3r, which is 2r into 1 plus root 3. So that's the side length of our triangle. So how can we find the area of our triangle? Well, then, clearly, the area, in fact, we'll just call that a triangle, is equal to half AB sine C, where AB are adjacent sides and C is the angle in between. Well, we know this is 60 degrees, we have this length, and we have this length, they're both the same, just an equilateral triangle. So that's 1/2 times, well, we know it's 2r1 plus root 3 times 2r1 plus root 3 times sine of 60. Well, that's equal to 1/2 times 2r squared. 2r all squared is 4r squared. Times that by a half gives us 2r squared. Times 1 plus root 3 squared. Sine 60 is root 3 over 2. So that's equal to root 3 r squared 1 plus root 3 squared. And well, the area of our circles, so that's all 3 circles, we'll call AC, is just simply 3 pi r squared. So what's the area? What's our ratio? Well, that's going to be area of the circles over the area of the triangles, which is 3 pi r squared over root 3, 1 plus root 3 squared r squared, which is simply root 3 pi over 1 plus root 3 all squared.